Ferrocyanide and aqua complex of iron are different colored in dilute solutions. Why? There are two complexes, and interestingly both the complexes contain ferrous ions. If you note this here, in this case also I have ferrous Fe2 plus, in this case also I have Fe2 plus. In spite of the fact that both of them contain same metal cation ferrous, why is it that they exhibit different colors? This is the question. Let's try to answer that. First of all, let's look at ferrous ion. What is the electronic configuration? Lovely. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Like this. Let's take the configuration and let's draw the crystal field splitting in each case. In case of ferrocyanide, you would find when the crystal field splitting happens, cyanide being a very strong field ligand, the splitting is going to be large. And aqua being a weak field ligand, the splitting may not be much. Right? How does it affect? Well, it affects very strongly. You have large delta O and you have small delta O. D6 configuration, if you have 1, 2, 3, 4, 5, 6 like this. This is original. And after splitting, what happens is 1, 2, 3, 4, 5, 6. Instead of jumping up, they pair up because delta O is very large. In this case, 1, 2, 3, 4, 5, 6 like this. So there is a difference in configuration and there is a difference in crystal field splitting parameter. Okay, so what does that mean? It means that now this is the background. This is the condition of ferrocyanide and aqua complex of ferrous. Fine. How do you see colors? What happens is when light from an actual source falls on any solution, okay, part of that light is absorbed. Some of those photons are absorbed by the solution and you are able to see only the remaining light. Okay. Now, whichever photons are absorbed, they have certain color and accordingly, since that color is removed from white light, what you are able to see is the remaining part of the color and that is how you see the color of any solution. Okay. Which photons are absorbed? It depends upon how much energy is needed to make this electron jump up from here to here. This is ground state, it moves to excited state, it has to move up by a distance delta O, up by an energy delta O. So, some high energy photons will be needed for this excitation. In this case, jumping up is not that difficult. So, relatively low energy is sufficient in this case. Since different amount of energy is required for excitation of electrons in both the cases, the wavelength of absorbed photon is different in both the cases. And since different colors are being absorbed or removed from white light, what remaining color which is seen by human remains becomes different in both the cases. And that is why ferrocyanide has a different color than aqua complex of ferrous. That, my dear, is a fairly accurate explanation. What is the regular one? Give us something in writing. It's a theoretical kind of questions, although I have given you a very accurate explanation. This is a routine answer. I don't like this answer much, but this gives you at least a written text to copy from. So I'm just removing myself from the screen. You can take a screenshot and feel happy about it. But if you add what I have said, that is definitely the more accurate answer.